HBA, also known as the Home Builders Association. Absolute awesome organization. I first joined the HBA back in 2005. It's an association. Back in the day, there was, what, 1,400 construction folks who were members of the HBA. It's a really good, you probably have heard about it, Byron. You've talked about the HBA. Perfect. Yeah, it's just a great organization. Highly recommend it as you advance in your careers in the industry. You think about joining and becoming a member. If you're in the residential construction industry, obviously you join the Home Builders Association. There is a commercial side. There's also kind of the commercial HBA, if you will, called the AGC. So it's a great opportunity for continuing education, wonderful opportunity for networking and getting to know people. But I'm a huge proponent. I was president of the HBA back in 2016. I'm kind of dating myself. But had loved every minute of it, so I highly recommend that. So Byron told me there's a couple people here who actually worked for a home builder. Who are you? Awesome. What did you guys do? Siding? Framing. Oh, that is terrific. So what companies did you work for? Whitaker? Okay. Excellent. So you've got some real good experience, understand what the construction residential is all about. So again, I'm all about helping you guys learn. If you want to chime in with any of your information, feel free. So this particular project, we're in obviously St. Charles County. We have a wonderful family from California who will move into this house probably 3-4 months from now as we get into spring and summer. What they loved about this area is obviously it's quiet out here, right? A lot of land, just a very beautiful area. So as far as the style of house, this is a ranch home. We all know that ranch home has the limit on one story and a half. Story and a half is where we keep the master bedroom on the main floor, and you have bedrooms upstairs. 2 stories, all the bedrooms are upstairs. So we're what they call a high performance builder. And what I mean by that is it used to be called green. I prefer the term high performance because we're going to focus on different things during the construction process, and as we walk through, I'll kind of point some of them out. Now, a lot of it's depending upon budget, so we'll talk about cost of different things as well. But the main thing is whenever you start building a house, whenever you start, we look at the wall assembly. How we put that wall assembly together is the most important part of the house because it's going to control the comfort of the house, it's going to control the heating and cooling bills and everything else. So one of the things that we pay really close attention to obviously is the exterior, making sure that you see all the windows are properly flashed. That's where it starts. The good construction, you never want to cut corners because if you cut corners, it can only lead to problems down the line. You'll have an unhappy client, you'll have callbacks, you'll have uncomfortable homes and things like that. So you just want to make sure that whenever you begin the framing process and the construction process, you really do try to do the very best job you can. Not only do you want to put your name on the best product, right? But you also want to deliver a home to the client that they are proud of, that they absolutely love. I mean, we have a saying around our office, we're building dreams one home at a time, which we really are. We're a custom home builder, so we've never built the same home twice. Everything we do is different. Unlike you guys were working for production builders. So production builders are guys that will go into bigger neighborhoods, and they'll have the same floor plan basically that you can change up a little bit, but then you can change the exterior. What does the exterior look like? Is there brick? Is there siding? Where are the gables? And how many windows and things like that. But as a custom builder, we've been building in the St. Louis area now 18 years, and we've never built the same home twice, and we think that's pretty cool. So anyway, from an exterior perspective, it's just you always want to do the very best job you can. Water is truly a builder's worst enemy, so that's why you make sure that every single penetration is sealed properly, the windows and doors are flashed properly, you've got your weather barrier installed properly, because it's really your name and your reputation. Even if you maybe aren't the builder, but you're the subcontractor, you want to do the very best job you can, okay? So let's move inside where it's a little bit warmer and we can start talking a little bit more, and I'll show you around the house, all right? So one of the things that I know Byron has talked to you guys about all the time is job site safety. And I can see everybody's wearing your safety glasses and your hard hats, and you've got your steel toe boots and things like that on. Absolutely perfect on a job site. We are very particular about safety as well. We have a safety consultant that we work with. He will visit our job sites periodically and actually, score how we do on our different job sites. So we're in school, so to speak, if you will, as well. We're part of a program it's run through the HBA in partnership with the OSHA, Occupational Safety and Health Administration. And they're the ones who are kind of in charge of making sure that commercial and residential job sites are safe for anybody working on it. So we have this partnership going. We're part of the ROSI program, which stands for Residential On-Site Safety Initiative. And so what we've said is we're making safety one of the most important things that we do. So we invite periodically the inspectors to come on our job sites and basically score us how we're doing. They look at everything from the safety of ladder placement. They look at extension cords. They look at pretty much anything and everything that has to do with job site safety. And so one of the things that we like to do is on our job sites, we want to make sure we have a fire extinguisher in case it's needed. We have a table here that basically lists a job site safety plan. We've got contact information, so if anything happens on a job site, we want to make sure people can get a hold of the proper authorities or the proper emergency personnel to come out here and help. So always, always, always make safety one of the most important things that you focus on, because you getting back home at the end of the day is far more important than how quickly a job gets done. Never cut corners if it means, never cut corners if it means you're going to sacrifice quality, and also if it's going to sacrifice your safety. So that's something that just always pay a lot of attention to as well. Okay, let's pop on inside here. What's that? No, isn't that nice? So one of the things that in talking about job site safety, you also want to make sure you're working around a very clean job site, because you don't want debris that you're stepping over, and you want to make sure that as you're walking around, obviously, that you're safe as well. So we have a team of laborers that work for us, and we probably have, I think, about 7 or 8 active projects going on right now. And so one of their duties is to make sure that when they visit the job site, they're making sure that the interior is clean, because not only do we want our trades who are working there to be safe, but also if the homeowner comes by, we want them to make sure that they're not stumbling over different pieces of lumber, drywall, and that type of thing. So where we are here right now, obviously you guys know this, we just insulated this house. And we are, you'll see the drywall has been stocked, so the drywallers actually are coming in within the next couple of days, and they're going to hang all the drywall. So we're kind of at the halfway point, if you will. So we're all framed up. We've done all of our mechanical rough-ins, our plumbing, our electrical, our HVAC, and we're ready for, in my opinion, kind of the fun part, which is starting to finish the house. So a couple of things and now I also want to mention that when we say we're a high performance builder, we try to build above the residential codes. Everybody knows what codes are, correct? Yeah, you have certain levels of construction quality that you have to build to. When we first started building our green or our high performance homes back in 2005, we were a builder that was always building above code every time that we built a house. It was our choice. So we would always upgrade our insulation, we would upgrade our HVAC systems, we would upgrade our wall systems and everything else. As the years have gone on and more municipalities and the federal regulators have gotten involved, those codes have kind of evolved. So where we were always building above code, because those codes were a little bit less stringent, if you will, every 3 years is the code cycle. So every 3 years they review the codes and they change them. So what we're finding is they're changing those codes and making them more strict. They're making changes so that builders have to pay more attention to things like the walls, the HVAC system, windows, and everything else that go into a house. So where we used to always be way above code, it's more challenging for us now to stay there. We still want to stay there because we as a custom builder, and one of our, kind of our market, one of the ways we market us is an above code builder. It gets more challenging for us because of the regulations leveling that playing field. But we like challenges, so we continue to look for ways to build a better home. Some of the things that we do that are different now, this is a typical insulation package, if you will, because again, we talk about budget. So this is a house that has the typical fiberglass back insulation in the walls, but if you properly install fiberglass batt, you can give the homeowner a well-performing house if you do a couple of other things. So what we did here is we actually built this house with, instead of 2x4 walls, we're using 2x6 walls, because we want to give them an extra couple of inches of insulation. So it's going to give you a more efficient house, but it's very quiet in here, right? So that extra couple of inches is going to make it more efficient, but it's also going to help with the sound. It's going to make it a quieter house. You'll also notice that around the doors, we've used spray foam insulation. This is low expansive spray foam insulation made specifically for around windows and doors. Back in the day, you used to see fiberglass that was just kind of stuffed in here, and that was not nearly as good of an air sealer and insulator as the spray foam. So you'll see more and more builders, especially the custom guys and the high performance builders, are using a lot of foam in their construction. You'll see like all the corners, there's a heavy bead of caulk here. Down here along the bottom plate, there's also very heavy beads of caulk that have been run, and that's part of the air sealing process. So what we try to do is control the airflow that comes into the building and that goes out of the building. It makes the home more comfortable. It makes the home more energy efficient for the client, and just much better indoor air quality. So as we're tightening up the house, and one of the things we do as well is, you know how you build your walls and then you stand them up once you have the subfloor? Our process actually starts, so underneath all of these bottom plates that you see here, before those walls get stood up, we run a very heavy bead of low or no VOC caulk under it, because when we stand up those walls, we want to begin our sealing process, and if we seal it up underneath the bottom plate, and then if we come along and we caulk along the bottom plates and in the corners and everything else, that only makes our air sealing process a little bit better. And the reason we use low or no VOC, you guys know what VOCs are, the volatile organic compounds. That's what off gases, and it's a process where if you use no or low VOC, you don't have that off gassing. So when you close up the house, when you heat it and cool it, you're not going to have any of those particles and some of the gases get into the air. So one of the things as a high performance builder is we really focus on all of the flooring that's going to go in here. As much of the paint, we use no VOC paint. So when you walk into our house after it's painted, it's not going to smell like a typical house that's been painted. We don't want that smell, those gases, to be in the house and trap the homeowner in there. We try as much as we can, even the paint finishes and the stain finishes that we use for flooring and cabinetry and everything else, to make sure that it's no or low VOC. Again, we do not want the off-gassing and to trap the client in the house with that going on. So anyway, back to kind of the performance package. It starts as we frame the house, and then it continues. I mean, it actually starts during the design, to be 100% honest with you, because we want to focus on things like when you have a lot, and it's harder for a custom builder because we don't always know, or the direction that the house can be placed on the lot really does make a difference. For example, the sun is in the summer and it's highest and it's hottest when it's in the southern sky, and then as it sets going to the west. So what you try to do is, when you're working with the architect, is you want to make sure that you place the house in such a position that you don't want your dining room to be maybe on the western side of the house or the southwest side of the house, because late in the day when you're trying to have dinner, you don't want all that warm sun coming in. So you can do a couple things about that. First of all, the placement of the house on the site is very important, but also the design of the house. You want to make sure that when you design the house, you're working with the client and having them understand sun angles. You want to have them understand things like overhangs, because you might want your dining room in an area that's going to get a lot of sun. Well, then what do you do there? You build a larger overhang. So maybe you have the sun that's up high in the sky, and at 4 o'clock, 5 o'clock in the afternoon, and they now have computer programs that can show you exactly sun positioning every single day, every single hour, so you can model it into your into the design. But you can use maybe larger overhangs that's going to block that sun from coming in. So there's a lot that goes into this when it starts with the design phase, and it's something that the architect will work closely with the client and the builder. Screening, you can, maybe again, if you want a window off your dining room, and it's a part of the house where you really want it positioned because of the flow of the house and everything. Landscaping is another great way to kind of block some of the solar angles and things like that. But then you can also use it to your advantage. For example, let's just say, I honestly don't know what direction we're facing here, but let's just say, for the sake of argument, this was south facing, right? And during the winter, you wanted to design the house in such a way that you would pick some materials and pick some glass and everything else that would help you. You can always do what you did up there, have a bank of windows that are high, and then the fireplace around, let's say that was constructed out of brick. What will happen is during the day, the sun comes in, the brick absorbs some of the heat. As the sun goes down, that brick is going to start releasing some of the heat back into the house. And it's going to help keep the temperature of the house a little bit warmer during the evening hours. So there's a lot of things that go into the design of the home, selecting the right materials for the home. And just there's quite a bit of planning, I should say, that really starts before the carpenters even show up, or the foundation crew shows up, or the survey crew shows up to stake out where the house is going. So from a high performance standpoint, we really start focusing on the house early on during the design phase. Once we get into construction, you'll see we've got the 2x6 walls. There's various forms of insulation. You guys, have you worked with what's called BIBS by chance? Okay, so that's called, BIBS stands for blown in blanket system. That's what we use a lot, but again, budgets will dictate which direction you go. The higher level of insulation, the more money you're going to spend, and budgets matter. So we work very closely with our clients to put the budget together, kind of move pieces around and figure out what's going to be best for their particular house. So BIBS is simply, you would come in here and you would put a net, a thin net across your studs here. And you'd have a hole high and a hole low, and you simply come in and you're blowing a thick bed of fiberglass insulation in the walls instead of the fiberglass batts. Benefits to it, probably fills that cavity a little bit more, but our insulation crew does such excuse me one second, our insulation crew does such a good job properly installing the batts that there's not a big difference between the two. But you can gain a better R value if you do use the BIBS system versus the typical fiberglass batts. Siding affects your R value. Siding also affects the performance of the house. For example, you guys are familiar with fiber cement siding versus regular vinyl siding. So the fiber cement siding is going to give you a little bit of a better R value. It's also fire resistant, rot resistant, mold resistant, costs more money. So those are some of the things that we have to talk with our client about all the way through. We start with kind of the wall assembly and the insulation package and work our way all the way up through the interior finishes. And so it's like a shell game where you're always moving money around until you get the right combination of finishes and the budget. And so the insulation, believe it or not, really does come into play. We have to work with our client, talk to them about the pros and the cons and how it all works, and kind of go from there. If you look over here, some of the other things that we try to do, most of the time you'll see this window here, we have our spray foam all the way around it as well. That air sealing pack is very important. But if you also look up here, you see this header, most of the time you have the blocking, solid blocking all the way through. Right there we've recessed our header, and the reason we recessed it is because we want to be able to get some insulation up there to at least help with the thermal bridging in this house. Everybody know what thermal bridging means? All right, so thermal bridging is Like where you have this stud right here on the outside of the house, and then you go to insulation, you have another stud and more insulation. Where this stud hits the exterior wall sheathing, that's created a thermal bridge because you don't have any insulation to insulate the house. So you've always got your weak points, and that weak point is where that stud meets the exterior sheeting. That's what it calls a thermal bridge right there. You got the, you know, the insulation kind of bridges the performance of the house, if you will. So we're paying more and more attention to that thermal bridging when you're considering the comfort of the home. And the reason we're doing that is because you want to deliver a home that stays consistently cool in the summer, warm in the winter. You want a home that's going to perform better. So that's why when you see some homes right now being built with insulation on outside of the wall, that takes away that thermal bridging. So you have a consistent layer of insulation all the way across it. We did something pretty cool at one of the homes that we recently built. In order to do away with thermal bridging, we actually built two by 4 walls, and we butted them up against each other. But what we did is we staggered our studs. So we would have one stud that was against the exterior sheeting, but another stud on that interior 2x4 wall we built was on the inside. And then we applied our insulation, and what that did is it took away all the thermal bridging because you never had one of your interior walls connected to the exterior walls. So it's a process that you'll probably hear more and more about as the codes continue to get tougher and tougher. But thermal bridging is something that you'll probably hear as you advance in your career a little bit, and it simply means you know, there's a break, a thermal break in between the insulation and the framing materials. More and more homes, and we didn't do it on this one. So this house was conventionally framed. So the carpenters came in, you know, framed the subfloor, they set the steel, they framed the subfloor, they framed the walls, they framed the roof sheathing and on. More and more homes, we're actually doing a home in Webster Groves here soon where we're going to be using what are called wall panels. So those panels are actually being built in a factory. They're being built in the same factory that builds the trusses. And so the carpenters will still do the subfloor, but then they'll come to the job site and the actual wall panels will be delivered on a tractor trailer, and they'll be, you'll offload them with a crane and you'll set them on the subfloor. And it's like a puzzle. It'll come with a map. And the wall panels are numbered. You'll have the you know, the information that will be provided will show you exactly where each one of those panels go. So it saves a lot of time, and you're going to find that because there is a shortage in the construction industry with many of the trades, builders are looking for ways to build the homes more quickly, so they can move on. And one of the ways that that's being accomplished is through wall panels that are being built in a controlled environment, delivered to the job site. Walls are all ready to be stood up, so you guys can imagine it saves quite a bit of time. Probably saves about a week off of the normal homes that we build, and that's a lot of time. Yeah, I'm sure you guys are aware that most of the roof trusses are manufactured right now in a factory and delivered to the job site and craned into place as well. Yeah, so there's a lot of changes. And then there's also what is called modular. You guys heard of modular building? A lot of times when I say modular, people think I'm talking about mobile. Well, I'm not talking about mobile homes at all. What I'm talking about are, these are truly modules of homes that are built inside of a factory. So they might take this wing of a house and then the center section of a house and another section of a house. And what they'll do is they'll build that in a factory. They'll take it all the way through electrical and plumbing and drywall, and then they will load it on top of a flatbed and deliver it to the job site, and then you kind of stack the modules in place. Then you have the plumber, electrician come in and finish everything up. But more and more of these construction methods you're going to be hearing about as you get in and more you advance into the industry, simply because we're looking for ways to build homes more quickly with fewer people and using less materials. And one of the benefits of doing wall panels in a factory is you can recycle that waste more efficiently and more effectively, because whatever's cut there, you can just throw it in a bin and recycle it right away. So things like that, you'll probably start hearing more and more about. All right, so we talked about, you know, the framing, the carpenters. After that, of course, we had the electricians come in. Nothing really there different from a high performance standpoint, except that we use a lot of LED can lights. We use a lot of LED lighting in general because we're trying to lower that, you know, the use of electricity. We're trying to limit that. HVAC, and we'll go downstairs here in a second, look at the HVAC system. That's where we also pay a lot of attention as well. So we've got 2x6 walls, so we've upgraded to an R19 in the walls. You'll see that once we install the drywall ceiling, the insulating contractor will come back. They will blow in, code is an R39. We're gonna go to, I'm sorry, R38. We're gonna go to an R49. So we're gonna go to a thicker level of insulation up in the attic. And the idea there is because we don't want a lot of the heat's gonna go where? Up. So the heat's gonna rise. We wanna try to keep it in the house. And going to that thicker layer of insulation is going to help us keep the heat in the house and the cold in the house in the summer and that type of thing. So what we're trying to do is really focus on what I call that thermal envelope. Anything that if you took a big blanket and laid it on top of this house, anything that blanket would touch, the roof, the walls, the windows and everything, that's what I call that thermal blanket or the thermal envelope. We're trying to build the best possible house with our thermal envelope, insulation, moisture barrier, water protection, everything we can, so we leave the homeowner with a house that's more efficient, more durable, cleaner indoor air quality, and more comfortable. It starts with that thermal envelope. That's why the carpenters are so important. The quality of the job that they do is critical, and I can't say that enough. Everything from how the walls are framed, to how the windows and doors are installed, how the roof is applied, and everything else, it's critical. Then we turn it over to the trades for them to do their work. Plumbing, not much there. We always, and we'll pop downstairs in a minute, but we always do prepare for radon. So we do a passive radon mitigation system we'll talk about. We focus a lot on the insulation, or I'm sorry, the HVAC system. We'll talk about that in a minute. Any questions while we're up here about anything you see or just the process that we go through? Yes?
What is this like pinkish reddish?
Oh, okay, so that's called fire caulking. Great question. And that's required because if there was a fire to happen to start in this house, you want to make sure that it's not going to be able to travel from stud to stud and really accelerate, if you will. So if you look around, and most of it's covered up right now because of the insulation, but there's many penetrations, and this one particularly because it's also a cold air return. We put fire caulk in there, so if a fire does start, it can't shoot out and accelerate the fire. But as you walk around the house, you'll see a lot of the penetrations have that reddish caulk that gets really hard when it dries. Other questions? Yes.
Why y'all have cut it like this stood? Why y'all cut it and slide it onto this? Like, can you see it on this side?
Nope. Let me take a look.
See how y'all cut it over here? And then y'all slid it onto this. Why y'all?
That is a good question. I don't know that I could answer that. That's the way the carpenters did it. You know, and this is not a load-bearing wall, so it doesn't have to have some of the same principles as some of your other headers and all. So I'm assuming that's just the way they did it. Probably my guess is for drywall purposes and everything else, but you'd have to ask the carpenters if they were here. But that's a good question. Anything else?
Is this like a bedroom right here?
This is going to be kind of like an office, if you will. Yeah, and the master bedroom is on this side over here. So this is the guest bedroom wing. There is a bedroom up over here. This is the master bedroom back in here. Yeah, they're continuing to change the materials we use almost on a daily basis. They continue to study what works the best, and so we're always adapting. So this is the master bedroom. Obviously, you can see that there's an attached master bedroom. Master bathroom is attached to it. Master closet. You'll see we've recessed the shower pan. This is going to be a zero threshold shower. so the client can go in and out of it very easy without any kind of curve. That is a great question. Let's talk about that when we get everybody together. I love that question. It actually doesn't. There are some people who say it does, but in reality it doesn't. We're talking about the PEX. The PEX piping. Yeah.
Yeah, that's all.
Yeah, we'll talk about that when we go downstairs because we'll get a good
Yeah,
look at
see,
it.
like that was copper, but it's like connected to plastic. like,
Right,
why
so
not
we
all, like-
we always terminate though in copper because first of all, whenever your supply for the toilet, for example, comes out of the wall, we want it to, visually look nice, and so we'll always terminate with copper. But the PEX is so much easier to work with, and it's a very durable product, easy to work with, longer lines. You don't have to sweat your copper joints together, so it's actually more dependable too. Yeah.
Y'all actually putting a hot tub in?
Yeah, there's going to be well, it says hot tub. There is going to be a jacuzzi type tub is what it's going to be. Yeah.
It's gonna be like regular?
That's going to go out to a deck, just a deck off of the master suite.
Okay.
Mhm.
I didn't wanna
It's a long way down.
Would all copper piping still like match the code now or something?
It would
Like
absolutely
it's still
match the code, but I don't know. There's very few builders who are actually using all copper right now. A lot of it's because of the cost. Keep in mind that especially in today's day and age, in the COVID era with supply chain shortages and cost increases, the price of copper would be astronomical. And so cost is one of the reasons many builders are using PEX, but PEX has been used in the St. Louis area for probably 15 years or more. Virtually all builders are using it now. Very dependable product. There is no sediment buildup inside of it. It comes in much longer runs, so it's easier to install. When you're working with copper, you have more connections, more joints to sweat together, more chance of failure. But like I say, the reason that we terminate it with copper is we want it to look good. It's not a performance thing, but we're all about we want it to look good for the client and be visually pleasing, and so that's why we do it. So the question, what we're talking about is the PEX. You see the white pipes, if you will, or tubing for how we're running our plumbing. And PEX actually started over in England, 30, 40 years ago. And you know what happens is everything will make its way to the coasts here in the States, the East Coast and the West Coast, and then it finally makes its way to the Midwest. So virtually all builders are now using PEX, and the reason I mentioned is because it's much easier to install, takes less time, and is a lot cheaper than copper. And most all construction, even commercial applications right now are using the PEX simply because of the cost, the ease to install, and the performance as well. All right, let's head this way. Follow you, Melody. By the way, Melody's behind the camera here. Say hi, Melody.
Hello. You can say hi to the Connors as well. Katie, Connor's on. So they're like, that's my house.
Very cool. So on this side of the house, we have the laundry room, we have a pantry, kind of where we came in off of the garage. Very popular design to keep everything convenient when you come in off the garage. Obviously, drop stations for phones and coats and things like that. That's a very generously spaced area. I really like the layout of this house. It flows really well. I love the vaulted ceilings. You see the vaulted ceilings obviously in the great room. And the reason we're doing all that with our truss manufacturer, it just makes it a lot easier, much more cost effective to do it as well. But when this house is done, it's just going to be, the layout is awesome. The performance is going to be exceptional. And like I say, it kind of all starts at the beginning with the design and then the selections of the materials and everything we're using. So let's pop on downstairs and have a conversation about some of the stuff there.
How many bathrooms are there? Like 6?
Okay, so one of the things that you'll notice is most all homes that are being built in this day and age have a 9-foot basement pour. I mean, back in the day, everything was 8 foot. And you'll notice if you look up there, that's one of the main soffits that, mechanical soffits that runs through the house, but it still gives you a lot of headspace above it, and that's because we have a 9-foot porch. So if you come into the main, kind of the rec room area here, I mean, you've got more space than you can imagine. So I would say that 80–90% of the homes being built today all have the 9-foot pour. That's something that's changed over the years. The other thing that we like to really focus on and take pride in is the fact that if you look up and see how all the mechanicals are run, it's very clean. I mean, you've got straight lines, you've got everything that's secured properly. You're never going to see this before, but again, it kind of comes back to image and doing the best possible job in everything you do. And so if you're a plumber, if you're an electrician, if you're working HVAC, take the time to really, do quality work and be proud of the work you do. Because yes, this is going to get covered up, but I promise you, you would go home at night and put your head on the pillow and go to sleep. And if you've not done the best possible job, I think you'd think about it a little bit. So just take that extra time. I mean, you can see every single one of those lines up there is just, it's perfectly run. The trades just did a wonderful job. Talking more about the performance, you can see the duct connections that we got here on our HVAC system. They're all, we have tape, and the reason we do that is because we want to make sure that whenever we're delivering heating and cooling to the homeowners, the various rooms that they're supposed to go to, we don't want to have any heating and cooling leaking out of there, because we do a duct layout, and we do a heating and cooling load calculations before the house is built, because we want to come up with the proper amount of heating and cooling to each one of these rooms to keep it comfortable for the client. So if we have a joint connection that maybe is starting to fail, and you have some heating or cooling that's leaking out of it, then maybe the master's going to get hot, or it's going to get cold, depending upon what part of the year is. And it's because that duct joint might fail a little bit. If we take the time to seal them, if you will, we know that we're going to be delivering the proper amount of CFMs, of heating and cooling, to that particular room. More and more codes, as I'm saying, are taking us in that direction where they're requiring it. But even in municipalities where they aren't, we absolutely either tape, or we do it with a heavy bead of water-based mastic and a paintbrush. We'll make sure that all of our connections are sealed, because we just want the performance of the house to be really good. I'm trying to think of anything else. Nothing else right here. I want to go back into the furnace room, so go that way and then turn left, and we'll talk about the heating and cooling system a little bit. Yeah.
What are these like?
Okay, so this is where we're going to have floor outlets for the homeowner. So those are going to be those are boxed out for the electrician to add the actual outlets themselves. Yeah.
I see you guys had a new type of wood joist too in here.
Oh, great question. We'll talk about that. You guys are really good. You're on the ball. All right, so it's getting a little bit darker back in here, but I want to go over a couple of things that we do pretty religiously on all of our equipment. First of all of our heating and cooling equipment is always above the code when it comes to the performance. So if most furnaces are 80% efficient, we want to be a minimum of 90% efficient, right? We want to provide the homeowners with equipment that's going to make their home as comfortable as possible. So a couple of things about this. First of all, you're going to see that all of our ductwork, again, is sealed properly. That's going to help the performance of the house. You'll see that we have an upgraded filter system that's on this one here. It's on its side right here. Most homes, you all have seen the filters that are maybe 3/4 of an inch or an inch thick, right?
Yes.
Yeah, so this filter, you can look at it there, is a good 4 inches thick. And so those are what are called MERV filters, and those filters will help filter out many more particles, dust, and anything that keep coming through this house. So it's going to, indoor air quality in this house is going to be much better, simply because one of the things we did is upgraded the filter system. But remember, we started by properly sealing the house, so we don't have air coming and going, we're controlling the air. We have an upgraded filter system, which is gonna keep the indoor air quality cleaner as well. So that's another thing that we do. And then you'll also notice on this, I'll come back and get that. You'll also notice we have a humidifier. That's something that, especially in Missouri, definitely needed, because in the winter, like a day like today, where your humidity is probably 20%, something like that. Indoor air quality in the winter, you want that humidity level to be somewhere near 40 or 45. And so, not only for the comfort of the homeowner, but we also want it for the performance of the house. We don't want the floors, which might start cracking and dry out and things like that, and even the drywall and everything else. So humidifiers are something that are very important for the house as well. And then this house is actually, you know, typically if you're going to zone a heating and cooling system, you have to have two furnaces, right? If you want to have the second floor on one zone and the first floor on another zone, you have to have two furnaces to control the temperatures that way. Because of the way we build our homes, we can build them tighter, so we can downsize our equipment. If we're building a tighter house, controlling the air that's coming and going, we can typically downsize our equipment a little bit, and we then will control the zones with automated dampers. So you see these two mechanisms up here, and you see these two trunk lines. This is actually zoning this house, but we're doing it with one system. And if one system is calling, if one thermostat is calling for heating and cooling, we're delivering heating and cooling there. If the other needs it, we're delivering it there as well. So we're still zoning this house, and there's different thermostats, but we're able to do it much more efficiently because we're doing it off of one system instead of two. So there's quite a bit of cost savings that way. And if you look at the water heater, the same thing. A very highly efficient water heater. If you walk into most homes with production builders, you see a flue that goes straight up from the water heater up and out through the house. That's how they ventilate the house. We do it differently. This is a power vent, because again, we want the indoor air quality to be as clean as possible. So if you can see, this is actually a fan right here. And then we have PVC that goes up and is running out the house. This is containing the off-gassing of this furnace. And so we're helping the indoor air quality of the house by controlling the exhaust of the water heater. So this fan is going to push it up and out the house, and that exhaust will never get into the house. And so that's why we prefer to use what is called a high performance direct vent. We're directly venting the exhaust of the water heater. This is also very quick recovery, highly efficient. So, you know, once the water is used, it's going to recover very quickly, but it's very efficient, so it doesn't use a lot of electricity when it's regenerating hot water.
I thought this was gas.
This is direct vent, power vent, gas water heater. Oh, I see what you're talking about. No, but it's quick recovery, I guess, is my point. But they do make these as electric. Same principle behind it. But you're right. This is a gas water heater. Exact same principle though with the electric. Yeah. Now the furnace is a gas furnace though. They just haven't connected the line. Questions about this system?
Yeah, what's this here? I've not seen that before.
That's the controller. So that's the control panel where you'll set you know, how hot you want the water, and it'll if there's an issue, it'll indicate what the issue is and things like that. So it's just the control panel. Yeah. That filter is definitely different. That's why I said this is where you got the 4 inches there compared to the real thin filter. It does a real good job.
Mine's so old, I don't have a product.
I thought they had one skin. I thought they
Oh, do you? Yeah, that's typical.
It still works.
Yeah.
It's like 2022. I'm like 14, 13. It's like, oh,
All right, let's see. So the heating and cooling system is something that's extremely important as well. We've talked about kind of the wall assemblies. Any other questions that you guys have come up with? Oh, the floor joists. Come on out here. Well, actually, let me do this. Stay here for 1 minute because I want to show you the differences in these floor joists. So if you look up, these are engineered floor joists that are being used in this portion of the building, right, the home. But if you look up over here and out in this other area, we again have engineered floor joists. And I know there was a question asked about why, or I guess somebody had mentioned the fact that we're using floor joists that are a little bit different, and you're absolutely right. So most of the time, or at least several years ago, most builders would use what they called a dimensional floor joist, which is lumber that's cut straight from the tree, and they would cut it into the size they need for your floor joist. So now they're actually engineering the floor joist. So these are floor joists that are still made from trees, but it's engineered. They're chipped up. There's resin. They're manufactured into the floor joist. Same with the subfloor material that we're using now. You can see what looks like little chips up there, right? The reason that we've gone in this direction is because there's a kind of a nickname for the floor joist. It's called the silent floor. They're manufactured straighter, they're manufactured longer, so you have longer spans, but you don't have any kind of imperfections that you used to have with the dimensional lumber, the lumber that's cut straight from the trees. Exactly, you don't have to crown them, you don't have to worry about twisting and everything that goes along with it. So using this, in theory, and it's proven out, it's giving the homeowner a floor that is just structurally more sound, less problems, quieter, that type of thing. Yeah.
Yeah. Wouldn't it just make it like the floor joist weaker? Because isn't that like glue or something? Right?
It is absolutely a resin, a glue.
Yeah.
Part of the problem that we as builders are facing now is with the pandemic and all, there is a shortage of that resin. So especially last year, there was a shortage of the floor joists. I can tell you that they have done studies on the floor joist, and they're actually stronger, if you will, or as strong as the dimensional lumber, and manufacturing them with the flanges, because these come in different sizes too, right? The flange right down here it comes in different sizes. The depth of the floor joist, they're all different. So they've been engineered, and they've obviously done the studies, so they know what the loads they can take and all. And they're straighter, they're longer spans, and they can absolutely carry the appropriate loads for the house that they're being used in. Now, if you remember, the ones that we used back in there, those are a different type of floor joist, right? They don't have the flange, they look a little bit different. The reason we're using those is there's a different fire rating between the two. So in here, we're going to have a drywall lid. We're going to have a drywall ceiling. So if there was ever a fire, that fire would have to get through the drywall, and it would take a while to get to the floor joist. So there's actually a burn rate difference. And in working with a lot of the fire departments and fire municipalities around the country, it's been determined the fire departments want to make sure, obviously, if there are men and women come into the house, that when they walk on the floor, that it's gonna be stable and they're not gonna have the risk of falling through. It's been determined that the burn rate on the typical floor joist is higher, and they're concerned about that. So if you have the drywall protection of the ceiling, there's no problem. The burn rate is fine. The fire department is good with that. But if there's not drywall on the ceiling, we have to use a different floor joist, which has a much longer burn rate, which would keep the firefighters safer inside the house. So that's why in areas where we're not finishing the lower level, or we're not finishing the ceiling, we use a different floor joist because of a different burn rate. Now, you had a question?
Have you ever built the house with metal studs?
Great question. We have done a house that has partial metal studs, primarily in the basement. Big cost difference between the two, and also from a standpoint of labor, the carpenters want to charge more for the installation of the metal studs. So it's used all the time, most of the time in the commercial world. We don't use it a lot in the residential world. Most of the time, everything we do, if we do it, it's primarily for a structural reason or possibly in the basement occasionally. Yeah. Okay, other questions? You guys have been great, really good questions. Melody, do you have anything you wanna?
No.
No? Okay. Byron, where are you?
I'm in the back over here.
What have I missed that you want me to go over?
You pretty much hit pretty much everything that they're going over.
Okay, yeah, I mean, they're sharp, they're really good. Like I said, the one thing that I'd like you to take away from this is from the standpoint of high performance building. Again, focus on a few different things. The wall assembly is critical. Insulation package, extremely critical. How that insulation is installed, like I said, the bath insulation in this house has been installed properly, so it's going to work very well. HVAC system is critical. We talked about a lot about it and how we were able to zone it off of one system, making sure all the ductwork is properly sealed, upgrading your filter system as well. And then the last thing is controlling the air that's coming and going. This house here and every house we build has a fresh air system built into it. We want to make sure that if we're building a tighter house, which we are, we want to make sure that we're introducing the fresh air when we want it to come in, and we're exhausting the stale air when we want it to go out. So it's being able to control that is extremely important, not only for the indoor air quality, but also the comfort of the house. So as a high performance builders, those are some of the things that we work on. And then to me, the cool thing is, as I said before, we've never built the same home twice. We've always gotten to design something that was unique. And that's the fun part about it. Each client has their own dreams and desires as far as what they want the house to look like. And so it's kind of fun to be able to make that happen.
And as a custom builder, because everything hasn't been built before, there's a lot of problem solving that you get to do because
that's a great point. Yeah, with every plan, if we had built this house before, or no matter what plan we work on, we know, because virtually every project you build, if you've never used those plans before, you'll run into, I call them pinch points or problem solving opportunities. Because you've never used those plans before, and you know, you have architects which are trained to design the homes, but they, you know, there's going to be little things that come up. So to a very good point, make sure that you know, problem solving is a big part of it. You want to, and we like to be able to you know, try to foresee things coming up, but it's virtually impossible if a plan's never been built before. Yeah.
What's the most common problem you run into?
I would say some roof connections, quite honestly, because you just don't know how some things are going to plane out with we do some really complicated roofs, and so a lot of the different connections that come in, a lot of times we end up with, and this is kind of slang, so you know, I apologize if I'm not meaning to offend anybody, but we end up with what we call idiot corners sometimes, because when you frame a house up, you might have this little corner that ends up there, and it's like, well, you know, what are you going to do with that? And so you try to get together with the homeowner or with your team and figure out, okay, we ended up with this area that we weren't expecting. This gives you an opportunity to come up with something really cool. Like we did that, we're building a house in Brentwood right now. And very cool design. It's kind of a contemporary house, and on the second floor there's a window upstairs. And when you walk upstairs, though, you don't realize there's kind of a little catwalk area, and the stair rail runs right into the window in the middle of it, right? You would think during the design we'd figure that out, but sometimes you just don't. So we got together with the homeowner, and the superintendent actually had a really good idea. It's got a great view of kind of the Brentwood Promenade area. And so all we did is, instead of running the stair rail right into the end of it, we turned the corner and made it look like the purposeful catwalk that continued right up to the window, turned the corner, and it gave you a chance to stand there and really enjoy the view. So it's things like that, just the unexpected, but you know, you get together. Same house, we ended up moving a couple of windows around after it got framed up. The owner was, I guess one of the windows looked over into an area that they didn't necessarily want to see, so we moved a couple of windows around. So with every build, there's things that come up. I mean, you're working with natural material, you're working with human beings. Things are going to happen. Things are going to get missed. It's just part of the process. What you try to do is limit the number, and then you try to react as quickly as possible and work through them.
we work in the shops.
Yeah, I
We
know.
work in a controlled environment.
Controlled environments in the shops, yeah.
So, when you speak to the fact of, like today, cold days, hot days,
So, that is a great question. I will say that our carpenters have already warned us that tomorrow they will probably not be working because it's gonna be 20 degrees. I know that on a really hot 95, 100 degree July afternoon, the carpenters, rework their schedules. They come in 5 and 6 in the morning, so they're off at noon or 1. Same with the plumbers, same with the electricians. We try to do the best we can to, keep a job site that's snow free. And I'm not sure why, and I know this place will be heated up soon because we're gonna start taping. But it is part of, it's part of the job. You just have to kind of resign yourself to the fact that, unfortunately, it might only be 3-4 months a year where you're dealing with the extremes one way or another, but it is part of the job. And most of if it gets really cold though, we don't expect the trades to be here week at it. Same thing if it's really hot. We know that you need to, for your safety, we talked about OSHA earlier. For your safety, you need to, reschedule maybe your day and you start earlier and you leave a little bit earlier. But unfortunately, it is kind of part of it. But as I said before, this is a wonderful industry. There is so much opportunity out there for you guys, and to be starting your careers at this stage, in this environment in which we find ourselves, where I think, Kelly, you might know this better than me, there's like 300,000 jobs in the construction industry across this country that haven't been filled. And we're talking all sorts of trades. And great benefit plans, vacations, retirement. And as I said,